Hi guys, welcome back to another video on RabbitMQ. In one of our previous videos we looked at a kind of conceptual overview of the use of some other exchange types as well as exchange-to-exchange routing. In this video we're going to look at the C# implementation of those concepts, and as usual we're using Visual Studio Code, and the link to all the code we write will be in my GitHub with the link to that in the description. We're going to look at exchange-to-exchange routing, the use of the headers exchange, and the use of the consistent hashing exchange in this video. So first let's jump into the use of the exchange-to-exchange routing. But before we do that, if you're more interested in a Python version of this video, please check out our previous video, which covers the exact same content but uses the Python programming language instead of C#. So we'll start with the producer code of our exchange-to-exchange routing example. And as usual, we're just starting with the very basic code that we had in our very first example using C# for a producer in our first video that had an implementation using RabbitMQ and C#. So we have the basic connection code, the declaration of a queue, and the publishing of a message. And in this example, we'll need to change a couple of small things here to support exchange-to-exchange routing. The first thing is, obviously because we're routing from one exchange to another, that we'll first have to declare two exchanges. So we can say channel.exchange declare, and our first exchange we will call just simply first exchange, and we'll declare that as a direct exchange. We'll then declare our second exchange here, and we will call it second exchange, and instead of a direct exchange we'll make this a fan-out exchange. And we don't need to declare a queue in our producer, as it will be the consumer that will be responsible for consuming off the queue. But what we do want to do is we want to bind one exchange to another in our producer. So we'll say channel, and instead of queue bind we can say exchange bind to bind one exchange to another. And the first parameter we want to say is the exchange where we want the messages to be routed to, which is basically the second exchange, and they're coming from the first exchange, which is the second parameter we need to give. We also need to provide a routing key here. In our case, we'll just leave it blank for now. We'll change what our message says from "this is my first message" to "this message has gone through multiple exchanges." And we'll publish in the same way, but instead of publishing directly to the letterbox queue using the direct exchange, we'll publish onto the first exchange. So that's it from our producer point of view, declaring two exchanges and binding them to each other, and then publishing a message onto one of the exchanges. Looking at the consumer code, again, we're going to use as a starting point the code from the very first example using C# and RabbitMQ. And what we're going to do here is we're going to set the consumer up to receive a message from the second exchange. So first the message will go to the first exchange will route to the second exchange like we've declared here, and then the second exchange will be responsible for pushing that message onto a queue and our consumer consuming it. So we first need to declare the second exchange here in case it hasn't already been declared by the time the consumer starts. And we can again declare the queue, so we can declare the letterbox queue, declare it with just all the default parameters. And finally we need to bind the queue to the exchange. So we say channel queue.bind, in this case instead of exchange.bind. And where do we want the message going? We want it going to the letterbox queue. And where's it coming from? It's coming from the second exchange. We also need to give this a routing key, which we will again leave as an empty string. And that's pretty much it from the point of view of our consumer. So let's open up a couple of terminal windows and run this, and let's see what happens. So we'd expect the message to go from publishing onto the first exchange, routed to the second exchange, and then the consumer will pull that message to the letterbox queue, and we'll see it here being consumed, having gone through both exchanges. So let's open a new terminal. So let's cd into our exchange-to-exchange routing example and our consumer, and run that using .NET run. So that's consuming fine. Let's open a second terminal. Again, cd into our exchange-to-exchange running example and our producer. And let's run that using .NET run. And we can see here that we sent a message saying this message has gone through multiple exchanges from our producer, and we have received that on our consumer. So it has indeed gone through the first exchange, the second exchange, and then finally pushed onto the letterbox queue before being consumed by our consumer code. So that's it for exchange to exchange rating. Let's take a look at using the headers exchange next. So we'll start off just by copying the code from our exchange to exchange example into our headers exchange. So the consumer code, just copy into the consumer, and the producer code into the producer. And we'll start here with our producer. So we don't need to make too many changes again here. Obviously, we no longer need to declare two exchanges. We're fine with just one, and instead of calling it first exchange, we'll just call it headers exchange. And it's no longer the exchange type direct, but the exchange type headers. Don't need to bind the two exchanges together. We'll change the message again, like we usually do, to say this message will be sent with headers. And we'll have that encoded with UTF-8. And then we need to publish it to the headers exchange. Don't again want to give it a routing key, but what we do want to do is we want to pass some properties which will contain the headers that we're going to set. So what we can say is var, so a new variable, properties equal channel dot create basic properties, and then on the properties we can say headers equals new dictionary of headers, so dictionary of type string object, and inside there we'll declare our headers. So our first header will just be name, and its value will be Brian. Just fix our typo, and then we're good to go. We can pass that properties in here instead of the null. So we're now publishing to the headers exchange, which is the exchange type header, and we're sending in the properties which contain this dictionary of headers, where the name is Brian as one of the headers. Let's jump over to our consumer code now. And again, we need to make some small changes here. We want to declare the headers exchange again here. Instead of type fan out, it is type headers. We still want to declare our queue and bind to our queue. So we're binding with the headers exchange, but we actually do want to pass some additional arguments here. And what we need to do is we need to pass these arguments here with our binding arguments. So we'll declare them in a variable called binding arguments, which again is a new dictionary of type string an object, and inside there we'll set our headers. So like we discussed in the previous conceptual video, we always need to set the X match argument when using the headers exchange, and the two types that are possible with that are all and any. We'll set all for now, and we'll set two more headers as our binding arguments. So we'll say name Brian, like on our published message, and age is 21, and then we'll pass those binding arguments into the queue.bind. So we're binding the letterbox queue to the headers exchange using these binding arguments. And what these binding arguments mean, as we've seen, is that when we publish a message with a header of either name Brian or age 21, because this is X match all, if the message isn't published with both these headers, it won't be sent to this letterbox queue using this binding. But if we set this to any, as long as the message we published had a header name of Brian or age of 21, then the letterbox queue would get that message. So we should be able to leave the rest of this the same. So again, let's jump into our terminals and run our code. So new terminal, we'll cd into our headers exchange example and into our consumer. And we'll run that using .NET run. Consumer has started. Open a second terminal. cd into our headers exchange example and our producer. And we'll run that using .NET run. So what we're expecting here is that because we've sent this message with the header name of Brian, and because this is bound with the header name of Brian and the X match of any, we expect the message to be consumed by the consumer. And indeed it is. We can see we've received the new message here in our consumer. So let's change it from X match all to X match any. Let's quit out of our consumer and let's start it again using .NET run. So that's restarted our consumer. And let's publish our message again. Now we can see that we've published the message on, but it has not been received by our consumer. And that's because it now has the X match all, which means that there has to be a name of Brian and an age of 21 on the message that's sent. But in our producer, we can see we're only sending it with a name of Brian. So let's jump into our final part of the video, which is looking at the consistent hashing exchange. So it's important to note that the consistent hashing exchange is not enabled by default when we install RabbitMQ. It comes bundled as a plugin and has to be explicitly enabled. So to do that, we can cd into where we've installed RabbitMQ. So cd/program files and RabbitMQ server, cd RabbitMQ server 3.9.8, and cd into the sbin folder. And then we can run the command RabbitMQ plugins enable RabbitMQ consistent hash exchange. And if we spelled that right, our consistent hash exchange should be enabled. So we can see here the following plugins have been configured. RabbitMQ consistent hash exchange. So let's jump back into our Visual Studio Code. And again, let's just start by copying in the consumer code from our headers exchange example. And the producer code again from our headers exchange example. We'll close up all these and close up the headers exchange. So we'll start with setting up our producer. So we'll jump in here, and we have currently using the exchange headers exchange. Let's use the exchange called simple hashing exchange. We'll get rid of the exchange name to keep it short. So just called simple hashing. And it's the exchange type we need to also set. So we'll set the exchange type to what is X consistent hash. So that's the exchange type we need to pass when we're declaring our exchange, and the name simple hashing. And we'll change our message to hello, hash the routing key and pass me on, please. We'll declare the body the same way. We no longer need properties, but what we do need to do is declare a routing key. So for now, we'll just call it hash me, and we'll pass that as the routing key here. We'll set the properties back to null. So what we're saying to RabbitMQ is to use the consistent hashing exchange, and then use this routing key or a hash of this routing key to determine which queue to send the message to based on the parameters that we've used to bind the queue to the X consistent hash exchange. So that's it from the producer. Our consumer code is slightly more complicated, but not much. So let's just copy this and jump into the consumer code. First thing we want to do is copy that exchange declaration in, so the same as in the consumer and producer. And what we're actually going to do here is we're going to declare two different queues, so we can get rid of these binding arguments, and we're going to declare a queue called letterbox1 and a second queue called letterbox2. And then we're going to again bind letterbox1 and letterbox2 to our simple hashing exchange. So letterbox1 and 2 to the simple hashing exchange. We don't need to pass in any binding arguments. But as the queue.bind routing key parameter here, we need to pass a numeric value. And this numeric value represents the hash space allocated to this binding. So if we say 1 and 3 here, for example, this basically means that this queue binding will take up, say, around 25% of the hash space, while this one here will allocate 75%. So for any one hash, it's more likely that it will be sent to the letterbox2 queue than the letterbox1 queue. But as we saw, the same hash will always be sent to the same queue because the binding remains the same, as long as you don't add more queues at a later time. So we'll create a new eventing basic consumer, and we'll say consumer1 received, and we will write out that Q1 received a new message. And in our basic consumer, we'll say basic consumer of letterbox1, and the consumer is consumer1, and we'll copy that again below here. Change this consumer2 received, and we'll say Q2 here, and then we'll bind letterbox2 to consumer2. So this way we're consuming off these two different queues, which are both bound to the simple hashing exchange using a slightly different routing key here, which again, as we said, represents the hash space. So as we send messages on, we'd expect most to be sent to the letterbox 2 queue, with about 25% sent to letterbox 1. So let's open up some terminal windows and see how this works. And we'll cd into our consistent hashing exchange example and our consumer. Let's run that using .NET run. Let's open a second terminal window. Again, cd into our consistent hashing exchange example. cd into our producer in this case. Clear it out for now, and then run that using .NET run. And it hasn't been received by our consumer, and that's because we're still publishing to the headers exchange here. So let's just go back into our producer and change that to the simple hashing exchange. And let's save it and run it again. And we can see that Q2, as we would have said, around a 75% chance of receiving that message, has received it. If we continue to publish the same message with the same routing key, which results in the same hash, Q2 will always receive that message. It will never go to Q1. However, if we start changing the hash even slightly, we might expect to start seeing some messages go to Q1. So in fact, the very first one we did go to Q1, even though we just changed one character of the message. We change another character, publish it, it again goes to Q1, so it's quite unlikely for that to happen twice in a row. I would expect we will start seeing more on Q2 now. So this one goes to Q2. This one also goes to Q2. This one goes to Q2 as well. So at the start we received more in Q1, but they seem to be going mostly to Q2 now. So you can never tell with a hash where it will end up. It's just more likely that it will end up on Q2 because the hash space is bigger. So I hope you enjoyed this video, guys. If you did like the implementations we've seen here in C#, please subscribe to the channel and like the video, and stick around for more RabbitMQ content.